Hello viewers, welcome to Hajjady math class. Today we shall be solving this question, which is 7 raised to power y plus 8 equals 8 raised to power y plus 7. Don't forget, this is an Olympiad question. And before we proceed, don't forget to like, subscribe to my YouTube channel. Today we are going to proceed with this. And for us to proceed, we are going to make use of the rules of indices. And don't forget that when you have s raised to power a times s raised to power b is the same thing as s raised to power a plus b. So these rules will be applied to this. So here I'm going to have 7 raised to power y times 7 raised to power 8 equals 8 raised to power y times 8 raised to power 7. Okay, so with this we can divide both sides by 8 raised to power y times 7 raised to power 8. So we divide both sides by that. So with this, 7 raised to power 8 is going to cancel out 7 raised to power 8. 8 raised to power y is going to cancel out 8 raised to power y. So I'm going to be left with 7 raised to power y divided by 8 raised to power y equal 8 raised to power 7 divided by 7 raised to power 8. And also, I can, using the law of indices also, I can bring out this power out. So here I'm going to have 7 raised to over 8, everything raised to power y, equals 8 raised to power 7 over 7 raised to power 8. So to both sides now, I'm going to introduce logarithm to both sides. And here I can have log this, also log this. Okay, and there's another rule for logarithm. When we have log a raised to power b is the same thing as b log a. So this is now going to be in form of my a, while this is going to be in form of b. So this can possibly come to the back. So with this, I'm going to have y log 7 over 8 equals log 8 raised to power 7 over 7 raised to power 8. Now, I can make y subject of the formula from this. So dividing both sides by log 7 over 8, log 7 over 8. So at the left hand side here, I'm going to have y equals log 8 raised to power 7 over 7 raised to power 8 divided by log over 8. So I'm going to use another law of indices, logarithm, that says that log a divided by b is the same thing as log a minus log b. So with this, I'm going to have log for the numerator 8 raised to power 7 minus log 7 raised to power 8. Also for the denominator, the same rule will be applied. So here I'm going to have log 7 minus log 8. That is what my value of y equals to. And from here, we can possibly say, using this same law that says log a raised to power b is the same thing as b log a, so the same thing can be applied here. So my y will be equals 7 can go to the back. So 7 log 8 minus 8 log 7, everything over log 7 minus log 8. And using our calculator, we are going to have that log 8 is the same thing as 0.9031, and also my log 7 equals 0.8451. So my y is going to be 7 into bracket 0.9031 minus 8 into bracket 0.8451. over 0.8451 minus 0.9031. So solving this, my numerator is going to give me minus 0.4391 over minus 0.058. So finally, I can say that my y is approximately going to be 7.571. So this is my final answer. Please don't forget to subscribe to my YouTube channel. Also like and also share. Welcome to another math class. Today we shall be solving this Math Olympiad question, and here we have that x plus xy plus y equals 54. So from here we should know that this can be written as x plus xy plus y equals 54, which is the given equation. So factorizing out here, we have x into bracket 1 plus y equals 54, and our intention is to find x plus y. So from here we can add 1 to both sides. Okay, so adding 1 to both sides, here we have x into bracket 1 plus y plus 1 plus y equals 54 plus 1. So with this we can have x into bracket 1 plus y plus 1 plus y equals 55. So with this, 1 plus y can be factorized from these two expressions. Here we have x plus 1 left equals 55. Now solving this forming a simultaneous equation from this, because looking at the factors of 55, we can say that 1 times 55 gives 55. Okay, and also we know that 5 times 11 gives 55, and also 11 times 5 gives 55, and lastly 55 multiplied by 1 also gives 55. And our condition here is that x and y are positive integers, and for our x and y to be positive integers, it shows that the value of our x must be greater or equals to 1, and likewise the value of my y must be greater or equals to 1. And looking at this, what satisfies this condition is only 5 and 11. Okay, these are the two conditions that satisfy this, because in this case now our x is not greater than 1, and here my y is not greater than 1. So we are considering these two conditions. So now solving further here, I can have that my x plus 1 is equal, this is when we have this to be 5, and also my y plus 1 is also equals to 11. This is the first condition. And second condition is that it can be that my x plus 1 equals 11, while my y plus 1 equals 5. Okay, that means s can be 11 and s can be 5 and s can be 11, and otherwise y can be 11 and also y plus 1 can be 11 and also y plus 1 can be 5. So now solving this simultaneously, you will agree with me that from here my x is the same thing as 4, and also from here my y is the same thing as 10. Just the same thing here, the value of x can be 10, and from here the value of y can be what? 4. So solving either way, my x plus y equals 14, and this solve our question. Math class. Today we shall be solving this Olympiad math question. Now here we have 0.01 all raised to power x equals to 11, and here the first thing we are going to do is to apply the law of logarithm. But before we proceed, kindly subscribe to my YouTube channel. Thank you. So here, applying the logarithm, we have log into bracket 0.01 all raised to power x equals log 11. And don't forget the rule of logarithm that says that when you have log a raised to power b, this is the same thing as saying b log a. So we are using the same thing. So this is coming to the back. So here we have x log 0.01 equals log 11. In addition to this, also we know that 0.01 is the same thing as saying 1 over 100, right? Which is the same thing as saying 10 raised to power negative 2. So using the same thing here, we are going to change 0.01 to 10 raised to power negative 2. So we have x log 10 raised to power negative 2 equals log 11. So applying the first law here, which is log a raised to power b, the same thing will be used here. So here we have negative 2x log 10 equals log 11. From the basic knowledge of logarithm, we know that log 10 automatically adds the base of 10, and log 10 base 10 is the same thing as 1. So here at the left hand side here, we are going to have negative 2x equals log 11. So from here, dividing both sides by negative 2, so here I'm going to have x equals negative 1 over 2 log 11. And still using the first law of logarithm here, here if I have b log a, it's still the same thing as saying log a raised to power b, right? So using the same thing here, I'm going to have my x to be equals to log 11 raised to power negative half. So from this, my x is the same thing as saying log 1 over root 11. And from the law of surd, in my previous video, I did the law of surd. So using one of the laws, I think that is the last law. So using it, when you have 1 over root 11, so rationalizing this means multiplying both numerator and denominator by the denominator. So here I'm going to have root 11 over 11. So you can check my video on law of surd on this. So from this, my x is now going to be log root 11 over 11. So this is the value of our x. Thank you very much for watching my video, and I will surely appreciate. Hello viewers, welcome to Hajjady math class. Today we shall be solving this question, which is 7 raised to power y plus 8 equals 8 raised to power y plus 7. Don't forget, this is an Olympiad question. And before we proceed, don't forget to like, subscribe to my YouTube channel. Yeah, today we are going to proceed with this. And for us to proceed, we are going to make use of the rules of indices. And don't forget that when you have s raised to power a times s raised to power b is the same thing as s raised to power a plus b. So these rules will be applied to this. So here I'm going to have 7 raised to power y times 7 raised to power 8 equals 8 raised to power y times 8 raised to power 7. Okay, so with this we can divide both sides by 8 raised to power y times 7 raised to power 8. So we divide both sides by that. So with this, 7 raised to power 8 is going to cancel out 7 raised to power 8. 8 raised to power y is going to cancel out 8 raised to power y. So I'm going to be left with 7 raised to power y divided by 8 raised to power y equal 8 raised to power 7 divided by 7 raised to power 8. And also, I can, using the law of indices also, I can bring out this power out. So here I'm going to have 7 raised to over 8, everything raised to power y equals 8 raised to power 7 over 7 raised to power 8. So to both sides now, I'm going to introduce logarithm to both sides. And here I can have log this, also log this. Okay? And there's another rule for logarithm. When we have log a raised to power b is the same thing as b log a. So this is now going to be in form of my a, while this is going to be in form of b. So this can possibly come to the back. So with this, I'm going to have y log 7 over 8 equals log 8 raised to power 7 over 7 raised to power 8. Now, I can make y subject of the formula from this. So dividing both sides by log 7 over 8, log 7 over 8. So at the left hand side here, I'm going to have y equals log 8 raised to power 7 over 7 raised to power 8 divided by log 7 over 8. So I'm going to use another law of indices, logarithm, that says that log a divided by b is the same thing as log a minus log b. So with this, I'm going to have log for the numerator 8 raised to power 7 minus log 7 raised to power 8. Also for the denominator, the same rule will be applied. So here I'm going to have log 7 minus log 8. That is what my value of y equals to. And from here, we can possibly say, using the same law that says log a raised to power b is the same thing as b log a, so the same thing can be applied there. So my y will be equals 7 can go to the back. So 7 log 8 minus 8 log 7, everything over log 7 minus log 8. And using our calculator, we are going to have that log 8 is the same thing as 0.9031, and also my log 7 equals 0.8451. So my y is going to be 7 into bracket 0.9031 minus 8 into bracket 0.8451 over 0.8451 minus 0.9031. So solving this, my numerator is going to give me minus 0.4391 over minus 0.058. So finally, I can say that my y is approximately going to be 7.571. So this is my final answer. Please don't forget to subscribe to my YouTube channel. Also like and also share. Hello viewers, welcome to the math class. Today we shall continue with our videos. And today we'll be solving 2 raised to power a minus 2 minus 2 raised to power b minus 2 equals 2016. Before we proceed, don't forget to like and subscribe to this channel. So with this question, we are going to use the rule of indices. And the first rule we are going to be using here is that don't forget that when you have s raised to power a over s raised to power b is the same thing as s raised to power a minus b. That is the first rule we are going to make use of today. So applying the same rule here, we are going to have 2 raised to power a divided by 2 raised to power b minus 2 raised to power 2 minus 2 raised to power b divided by 2 raised to power 2 equals 2016. And don't forget that 2 raised to power 2 is equivalent to 4. So this is the same as saying 2 raised to power a over 4 minus 2 raised to power b over 4 equals 2016. Multiplying 2 by 4. So we are going to have 2 raised to power a minus 2 raised to power b equals 4 times 2016. So here is the same thing as saying 2 raised to power a minus 2 raised to power b equal 8064. So let's call this our equation 1. Now we are going to form equation 2. Okay, since that we have 2 raised to power a minus 2 raised to power b, one thing we are very sure of is that our 2 raised to power a minus 2 raised to power b, the value is surely greater than 0. We are very certain of that. So it tells us that our a will be greater than our b. We are certain of that. So now I'm going to say let my a to be equals to b plus, let's say, y. Okay, where my y is an integer. So let a equals b plus y, where y is an integer. Now going back to this equation 1, this equation 1 can be written in another form. Since my a is now equals to b plus y, so I can say that my equation 1, so we'll be writing equation 1. So I'm going to have 2 raised to power b plus y minus 2 raised to power b equals 8064. So using the law of indices that says that s raised to power a, s raised to power b is the same thing as s raised to power a plus b. So here I'm going to have 2 raised to power b, 2 raised to power y minus 2 raised to power b times 1 equals 8064. So with this, factorizing out 2 raised to power b, which is common to both sides. So here I'm going to have 2 raised to power b factorized out, which is going to give me 2 raised to power y minus 1 in bracket equals 8064. So I'm going to have this in bracket. So with this, using the LCM method, that's going to be a long process, but using the LCM method, we are going to have that 8064 is equivalent to 2 raised to power 7 times 63. Yes, you can do this and you will see that this is equivalent to 8064. So I can transform this equation to 2 raised to power b into bracket 2 raised to power y minus 1 equals 2 raised to power 7 times 63. Now comparing these two, you can see that this is equivalent to this, while this is equivalent to 63. So here I can say that my 2 raised to power b equals 2 raised to power 7, while also my 2 raised to power y minus 1 is equals to what? 63. Minus 1. So from here, equality of base. So I have that my b equals 7. And here I have that my 2 raised to power y equals 63 plus 1. So my 2 raised to power y is the same as 64. My 2 raised to power y is also equals to 2 raised to power 6. And here I can say my y equals 6. Now I have equals 7, my y equals 6 also. And don't forget that we are interested in getting the value for the a and also for b. So, and from this, we have that our a equal b plus y. So now, since our a is equals to b plus y, so my a is now going to be 7 plus 6, and finally my a equals 13. So in conclusion, I have that my a is 13 and also my b is 7. Thank you very much for watching my video. I really appreciate you all for subscribing, and don't forget to subscribe if this is the first time of watching my videos. Hello viewers, welcome to Hajjady math class. Today we'll be solving this question on Olympiad. Yeah, before we proceed, if this is the first time of watching our videos, we say a very big thank you to you, and please don't forget to subscribe. And to our returning viewers, thank you very much. Yeah, today we have the 147 raised to power x equals 189. Then look for what is the value of 7 raised to power 1 minus 2x over 3 into bracket x minus 3. Now for us to do this, don't forget here we are having 147, and then 147 can be written as the multiple of what? 49 and 3. So our 49 can be written as 7 raised to power 2 multiplied by 3. Also, we have that 189 can be written in the form of 7 multiplied by 27, and 27 also can be written in the form of what? 3 raised to power 3. Now, having known this, we are coming back to this, and from here, so our 147 can be written in this form of 7 raised to power 2 multiplied by 3 all raised to power x equals 189 can be written as 7 multiplied by 3 raised to power 3. So now rewriting this, we know from the rule of indices that if you have x y raised to power a is the same as saying x raised to power a multiplied by y raised to power a. So adopting the same method to solve this further, we have 7 raised to power 2x multiplied by 3 raised to power x, which is equal to 7 multiplied by 3 raised to power 3. Okay, solving further now, this is almost the same thing as having 7 raised to power 1. Okay, 7 raised to power 1 is equivalent to 7. Now we intend to make the 7s to be on one side and the 3s to be on the other side. So we can do that by dividing both sides by 7 raised to power 2x multiplied by 3 raised to power 3. 7 raised to power 2x multiplied by 3 raised to power 3. Okay, so this can possibly cancel out. Also, this can cancel out. So at the left hand side, we are having 3 raised to power x divided by 3 raised to power 3 equal 7 raised to power 1 divided by 7 raised to power 2x. Now using the method of indices again that we have when s raised to power a over s raised to power b, the division rule, we are going to have s raised to power a minus b. You can check some of our videos on indices. Now, At the left hand side here, we are having 3 raised to power x minus 3 equals 7 raised to power 1 minus 2x. Now, in order to simplify this further, multiply the root of both sides by 1 over x minus 3. 1 over x minus 3. So here x minus 3 can cancel out. Oh, okay. Let's proceed with this. We are having 3 on this side equal 7 raised to power 1 minus 2x over x minus 3. So we want to multiply the root of both sides by 1 over 3 again. 1 over 3, yeah. So here we are going to have, at the left hand side here, we are having the cube root of 3 equal 7 raised to power 1 minus 2x all over 3 into bracket x minus 3. Now looking at this and this, you can see that this correspond with what we have here. So that means the value of this is the same as square root of 3. So finally, coming back here, we can say that this is equal to what? Cube root. From here, it should be the cube root of 3. So this is equivalent to the what? The cube root of 3. Or we can say that it's equal to 3 raised to power 1 over 3. Thank you very much for watching my video. Please don't forget to subscribe to my channel. See you next video. Thank you. Hello viewers, welcome to Hajjady math class. Today we'll be solving this mind-blowing Olympiad question. Before we proceed, please kindly subscribe to our channel, like and comment on this video. Thank you. Now looking at this, we have if x plus 1 over x equals minus 1, find s raised to power 8 plus 1 over s raised to power 8. So this is unknown. Okay. Now the first step we are going to use here is to work on this equation given to us, and looking at that, our step 1. Okay. Now we have x plus 1 over x equals minus 1. Now finding the LCM of these, we have the LCM to be x. Let me divide this into 2. So finding the LCM of these, we have 1 in x to be x, multiplied by this, we have x squared. X in x is 1, multiplied by 1, we have 1 equals minus 1. Okay, cross multiplying this, we have x squared plus 1 equals, this multiplying minus 1 gives minus x. So combining this into an equation, we have x squared plus x plus 1 equals 0. Okay, let that be our first equation. Now our step 2. Don't forget that if we have a raised to power 3 minus b raised to power 3, this can be written as a minus b into bracket a squared plus 2ab plus b squared. Okay, this is the basic expansion theory that we all know. So if we expand this, we are going to add the left hand side. So now using this equation to form this, given that we have s cube minus 1 cube, so comparing it with this, we are going to have what? X minus 1 x squared plus 1 times x plus 1 squared. Okay, so that means this can be written more explicitly as s minus 1 x squared plus x plus 1. Okay, and don't forget that this, from this equation given to us, let me call this equation 3. Okay, from this equation 3 given to us, the value is equivalent to what? 0. Okay, so that shows that our s cube minus 1 cube is the same as s minus 1. This is now 0 times 0. Okay, this shows that we have s cube minus 1 cube is the same as 1 equals 0 times any value is what? 0. So s cube will be equals to 1. Okay, now we've known this. Okay, now let's go straight to step 3. We are going straight to step 3. Now in our step 3, don't forget that we have s raised to power 88 plus 1 over s raised to power 88. Okay, so now let's rewrite this. We have s raised to power 88 plus 1 over s raised to power 88. Now splitting this s raised to power 88, don't forget the rule of indices that says that a raised to power m times a raised to power n is the same as a raised to power m plus n. Okay, so we are adopting this to simplify this further. So here we have s raised to power 1, okay, times s raised to power 87, okay, plus 1 over this. We are applying the same rule here. 1 times s raised to power what? 87. Now solving this further, we all know that 87, s raised to power 87 can be splitted as s raised to power 3 times 29. That is, 3 times 29 is the same as what? 87. So this shows that, and also our s raised to power 3 is equals to what? Is equals to 1. Let's call this from equation 4. So from equation 4, s raised to power 3 is the same as what? 1. So that is what we are substituting in here now. So this shows that s raised to power 87 is the same as 1, okay, raised to power 29. So that is s raised to power 87 equals 1. Okay, so more importantly, coming back to this equation now, we have x raised to power 1 times s raised to power 87 is now 1 times 1 plus 1 over s times 1. So finally we have this as x plus 1 over x. This shows that this is the same as what? Minus 1. So that shows that the value of this and this are equal. Thank you, and please don't forget to subscribe to our channel, like, comment on this channel. Thank you. See you next video. Hello viewers, welcome to Hajjady math class. Today we shall be solving this Olympiad question. Now looking at this question, it says that if x squared over y squared plus y squared over x squared equals 7, find x over y plus y over x. So what is the value? This is unknown. Now looking at this, we are going to see that this is a quadratic equation, while this is a linear equation. So solving this, we should know that the first step in doing this is that this can be expressed in this form. If you have x over y plus y over x all squared, expanding this, okay, we are going to have x over y all squared plus this y over x all squared, and also 2x over y over x. The method used in this is when we have x plus a all squared. Don't forget this is the same as x squared plus a squared plus 2 times x times a. Okay, so that is the short method for expansion. So that was the same thing that was applied here. So solving this further now, we should know that x can possibly cancel out x, while y cancel out what? Y. So this is going to give us x over y all squared plus y over x all squared plus 2 into bracket 1. And from the expression, don't forget that this is the same as this. Okay, so this can be expressed as x squared over y squared plus y squared over x squared plus 2. Now looking at this is the same as the first equation given to us up here. So mathematically speaking, you will agree with me that this is the same as what? 7 as given in this. So we have x over y plus y over x. So by substituting this with respect to this, we are going to have 7 plus 2. So our x over y plus y over x all squared gives what? 9. And from the question, we are looking for x over y plus y over x. So the next thing for us to do is to what? Square root both. Squaring both sides, this square cancel out this, and finally we have x over y plus y over x equals plus or minus 3. So this is our final answer. Please don't forget to subscribe to our channel, like and comment. Thank you. See you next video. Hello viewers, welcome to Hajjady math class. Today we shall be solving this Math Olympiad question. Before we proceed, kindly subscribe to my YouTube channel. So in solving this, we have that our a raised to power 3 plus a raised to power 2 minus 36 equals 0. So we are going to look for the root of the equation of a. And from here, when we substitute in a equals 0, 1 and 2, we can see that we're not going to get 0 here. So when a is 3, from here we can get that a is one of the roots of the equation. That is, a raised to power 3 is 27 plus a raised to power 2, which is 9, minus 36. This is going to give us 0. This shows that a is one of the root of the equation. But here we need to get the other two roots. So in solving this, we can use the polynomial approach. But instead of using the polynomial approach, I prefer to use the factorization method. So from here, we know that when we have a raised to power 3 minus b raised to power 3, this can be factorized in the form of a minus b into bracket a square plus ab plus b square. And also, when we have a square minus b square, this is a form of difference of two squares, which is the same thing as a plus b and also a minus b. So this is one of the basic principles of factorization. Yeah, solving this forward, this can be expressed in the form of a raised to power 3 plus a raised to power 2 minus 36 is the same thing as saying we have 27 and 9. Okay, so this shows that this can be expressed in the form of 3 raised to power 3 plus 3 raised to power 2. So from here, this can be simplified further as a raised to power 3 minus 3 raised to power 3 plus a raised to power 2 minus 3 raised to power 2 equals 0. Now, with this, a raised to power 3 minus 3 raised to power 3, we can use the rule of a cube minus b cube. So this shows that this is the same thing as writing a minus 3 a square plus 3a plus 9. And also for this second part, which is a square minus 3 square, we're going to use this rule of a square minus b square, which is the same thing as saying we have a plus 3 a minus 3 equals 0. So with this, we can see that a minus 3 is common to both sides, which can be factorized out. So here I'm going to have a minus 3 being factorized. So we are left with a squared plus 3a plus 9, okay, plus a plus 3, which is equals to 0. So from here, we can solving what is inside the bracket here. So I'm going to have a minus 3. Here I'm going to have a squared plus 4a plus 12 equals 0. So from this, I have that my a minus 3 equals 0, which is one of the roots, and also a squared plus 4a plus 12 equals to 0, which is one of the roots. Like stated earlier on, from here my a can be equals to 3. And solving this using the quadratic formula approach, I can use minus b plus or minus root b squared minus 4ac over 2a. So solving this further, I can have minus 4 plus or minus root b squared, which is 4 squared minus 4 times a times c, which is 12, all over 2a, which is 2 times 1. So with this, I'm going to arrive, by factorizing this, I'm going to arrive at negative 2 plus or minus 2 root 2i, which is in form of a complex root as the root of my equation. So finally, I can say that my a equals 3, that's the first root, and also my a can be said to be negative 2 plus 2 root 2i, and lastly, my a can be negative 2 root 2i. Thank you very much, and please don't forget to subscribe to my YouTube. Welcome to Hajjady math class. Today we shall be simplifying this question. Please kindly subscribe to my YouTube channel. Now in simplifying this, we need to convert this to fraction likewise this. So from here now we have square root 36 over 10 minus root 16 over 10. From the law of sort that we've treated in our previous class, we know that this is the same thing as saying root 36 over root 10 minus root 16 over root 10. And the square root of root 36 is the same thing as 6 over root 10. Don't forget that 10 is not a perfect square, so you can easily find the square root. While also the square root of 16 is 4 over root 10. And finding the LCM of these, we have the LCM to be root 10. And here we have 6 minus 4. So from here, we have 6 minus 4 to be equals to 2 over root 10. From the law of sort, there's a need for us to rationalize, and by rationalizing this, we multiply both sides by the denominator, which is times root 10 times root 10. So 2 times root 10 gives us 2 root 10. From the law of sort, root a times root a is going to be a. So root 10 times root 10 is going to give us 10. So dividing this to the lowest term, we have 2 here 1, we have 2 here, 5. So finally, my answer is going to be root 10 over 5. Thank you very much. Please don't forget to subscribe to our YouTube channel. See you next video. Thank you. Welcome back to Hajjady Math class. Today we shall be solving this question, and we're going to start from the last one here. That is, we are solving this first. Now, in solving this, we have that root x dot multiplied by x raised to power half, because we know that the square root of x is the same thing as x raised to power half. Okay, so multiplying this, also this is having the power of 1, so multiplying the two together, so here we are going to have square root of x square root of s raised to power 3 over 2. So the same law will be applied to this. So we are having square root of x multiplied by s raised to power 3 over 2 raised to power half all over x. So from here, I'm going to have square root of x multiplied by s raised to power 3 over 4 all over x. So this is also the same thing as saying s raised to power 1 times s raised to power 3 over 4. So here I'm going to have s raised to power 1 plus 3 over 4 is going to give me 7 over 4, okay, all over x. So from this, taking out the root here, I'm going to have s raised to power 7 over 4 multiplied by half all over x. So here I have s raised to power 7 over 8 over x. So applying the rule of indices also, I'm having s raised to power 7 over 8 divided by x over 1, which is the same thing as s 7 over 8 minus 1. And finally, I'm having s raised to power negative 1 over 8. So this is my answer. Thank you very much for watching my video. Please kindly drop your suggestion to the comments in the comment section. Thank you. See you next video. Hello viewers, welcome to Hajjady Math class. Today we shall be simplifying this expression given to us. So we have 2 raised to power 18 minus 1. So here we know that our 2 raised to power 18 can be written in the form of 2 raised to power 9 raised to power 2 minus 1. And 2 raised to power 9 raised to power 2 is of the form of indices that says a raised to power b raised to power c is the same thing as a raised to power b times c. So the same rules is what is being applicable here. And when we have this, we can possibly use difference of two squares by saying 1 raised to power 2, which is still the same thing as the expression we have previously. So using the method of difference of two squares, we can say that this is the same thing as 2 raised to power 9 plus 1, 2 raised to power 9 minus 1. And the 2 raised to power 9, that can easily be known as 2 raised to power 2 is 4, raised to power 3, 8, raised to power 4, 16, raised to power 5, 32, raised to power 6, 64, raised to power 7, 128, raised to power 8, 256, and raised to power 9 is 512. So just multiply each by 2. So here we have 512 plus 1, and here we have 512 minus 1. So here we have 513 multiplied by 511. So we have 530 multiplied by 511, and this 530 can be splitted as 500 plus 13 and also 500 plus 11. Okay, so from here, let's distribute this. That is, let's expand. This is the same as saying 500 multiply by 500, okay, plus 13 multiply by 500 plus 11 multiply by 500 plus 11 multiply by 13. So here we can have 500 multiplied by 500, which is 5 times 5 is 25, and we have 4 zeros, that is the 2 zeros combined together, plus here 500 and 500 is the same. So you can factorize that out as 13 plus 11 plus 11 times 13. That can easily be done, and that is going to give us 143, because 11 times 11 is 121. And adding 22 to 121 is going to give us 143. So here we have 25000 plus 500 multiplied by 24. Yeah, plus 143. I want you to remember something, that 24 multiplied by 1000 is the same thing as 24,000. And 500 is half of 1000. So that means half of this is going to give us what? 12,000. So that means 500 multiplied by 24 is going to be 12,000. So we have 250,000 plus 12,000 plus 143. So adding these together can be easily done. And these we are going to have 262,143. So this is what we have when we simplify this. So what you observe is that 2 raised to power 18 cannot be easily be multiplied out without the use of calculator. So breaking it down in this form, it is easier for us to get our answer. Thank you very much for watching my video. Kindly subscribe to my channel. Welcome to Hajjady math class. Today I'll be finding the value of x. So from here, we have that 2 raised to power x plus 2 raised to power 3x equals to 10. So the first thing we are going to do is that let y to be equals to 2 raised to power x. So if our y is raised to power 2, if y equals 2 raised to power x, so we can say that y raised to power 3 is the same thing as 2 raised to power 3x. Okay? So because from here, we should know that this is more or less like saying 2 raised to power x and 3 is outside. So since there is y, so we have y raised to power 3. So from here, so our given question is now going to be y plus y raised to power 3 equals 10. So from here, we can form an equation which is y raised to power 3 plus y minus 10 equals 0. And let my plus y be equals to minus 4y plus 5y. Okay? So, which is the same thing as plus 1y, right? So, we can use any other value, but for the purpose of this, I'm using these two. So, here, I have y raised to power 3 minus 4y plus 5y minus 10 equals 0. Now, let's factorize out. So from here, I'm going to have, let me factor out y. So I'm going to have y squared minus 4. And from here, let me factor out 5. So here I'm going to have y minus 2 equals 0. So the next line after this, looking at y squared minus 4. we can see that we can use the difference of two square approach to this, which means that here we can have y squared minus 4, which is y squared minus 2 raised to power 2, right? So here we have y plus 2 y minus 2. So plus 5 y minus 2 equals 0. Now factoring out y minus 2 from both sides here, I'm going to have y minus 2, which has been factored out. So I'm going to have y multiplied by this and this. So we are going to distribute y to this value here. So here I'm going to have y raised to power 2 plus 2y. And also plus 5, which is this, okay, since this has been factored out. So equals 0. So from here, we can have that my y minus 2 equals to 0. That is the case 1, right? That's our case 1. So let me call that case 1. So if my y minus 2 equals 0, let me solve the case 1. We have that y equals 2. And recall that from here, our y equals 2 raised to power x. That is 2 raised to power 1, which is the same value as y, equals 2 raised to power x. So therefore, with my case 1, my x equals 1. That's for case 1. So also for case 2, we have that our y squared plus 2y plus 5 equals 0. That is my case 2. So here we want to check if we have real roots here. And the easiest way for us to check if there's real roots is that we have our delta to be b squared minus 4ac. Don't forget, my a from here is 1, which is the coefficient of y squared. My b is 2, and my c is 5. So my b squared, which is going to be 2 squared minus 4 times a times c, which is 5. So I'm going to have 4 minus 20, which is what? Negative 16. So from this negative 16, which is less than 0, so we don't have any real roots from this. And since we don't have real roots, so we can conclude. Conclusively, we have that our x equals to 1 will be the only value for x from this. Thank you very much for watching my video. I will really appreciate if you have some suggestion in the comment section, and please don't forget to subscribe. Hello viewers, welcome to Hajjady math class. Today, as usual, we will be solving Olympiad math question. If this is the first time of watching our videos, please kindly subscribe. And to our returning viewers, we say a very big thank you to you. Now today we'll be solving this mind-blowing question. We have 1, 2, 3, 4 squared plus 1 over the denominator. What is the value? Looking at this, you observe that the values are very close. So we say let y to be equals to 1234. Okay, so we should know that if this should decrease by 1, it is equivalent to what? Y minus 1. So it means that will be 1, 2, 3, 3. That shows this decrease by 1. And when the y decrease by 2, we have it to be increased by 1. Sorry. That means we have it to be 1, 2, 3, 5. Now substituting this into the given equation that we have here, we have the numerator to be what? Y squared plus 1 over the denominator, this is y minus 1 all squared plus, this is our y, we have this to be what? Y squared plus, this is what? Y plus 1, okay? So we have this to be y plus 1 all squared plus 1. Now solving this further, we have this to be what? Y squared plus 1 over, expanding this bracket, we have this to be y squared minus 2y plus 1 plus y squared plus, this is going to be y squared plus 2y plus 1, and we have our plus 1 here. So with this, we have this to be y squared plus 1 over y squared plus y squared plus y squared gives 3y squared minus 2y cancel out plus 2y. So we have 1 plus 1. So we have 1 plus 1 plus 1, we have 3. So with this, we have y squared plus 1 over, factorizing 3 here, we have y squared plus 1. And with this can easily cancel out this. And finally, our answer is 1 over 3. Thank you. Please subscribe to our channel. See you in the next video. Hello viewers, welcome to Hajjady Math class. Please, if this is the first time of watching our videos, kindly subscribe. And to our returning viewers, we say a very big thank you to you. Now today we'll be solving this question. We have 1 over 5th root of 6y minus 5 equals 0 factorial. Mathematically speaking, we know that 0 factorial is equivalent to what? 1. It is the same as 1. You can press your calculator to confirm that. So that shows this is taking the place of what? 1. So here we have 1 over the 5th root of 6y minus 5 equals 1. So the next thing we are doing here is to what? Cross multiply. This multiply this while this multiply this. So if this multiply this, we have the 5th root of 6y minus 5 to be equals to 1 times 1, we have 1. Now, the method of indices will be used there. And for us to do that, we are going to raise the power of both sides by what? 5. So we raise the power of both sides by what? 5. So raising the power of both sides by 5, so 5 can cancel the 5th root. I hope you know this in indices, okay? So here we have 6y minus 5. 1 raised to power anything is what? 1. So from here we have 6y equals 1. If minus 5 is coming to the right hand side, it turns to plus 5. So we have 6y equals 6. Divide both sides by the coefficient of y, which is what? 6, which is what? 6. Finally, our y equals 1. Thank you, and please don't forget to share our videos. See you in the next video. Subscribe. Welcome back to Hajjady Math class. So we will be solving this question. So solving this, the first step for us to do is to equate to what? To a, where my a is assumed to be greater than 0. So the next step is to square both sides. So squaring both sides, I'm going to have a squared equals 2 root 4 plus root 63 over 2 plus root 4 minus root 63 over 2 all squared. And don't forget that when you have x plus y all squared, it's the same thing as saying x squared plus y squared plus 2xy. So I'm going to assume this is my x while this is my y. So using the same approach. So squaring this, so it's going to take away the square root. So I'm going to have 4 plus root 63 over 2. So squaring this is going to take away the square root 2, which is going to stand for my y. 4 minus root 63 over 2 plus 2 times x times y, which is plus 2, putting it in bracket. So I have roots, they both have the root, which is 4 plus root 63 over 2, 4 minus root 63 over 2. So, root 63 over 2 cancel out with 63 over 2. So my a square is going to be 4 plus 4, which is 8, plus 2. So multiplying these out, I'm going to have root 4 times 4 is going to be what? 16. Minus, if this multiply out, so this is still going to cancel this. With 63 is going to cancel this. So you're only going to have difference of two squares. 4 multiplied by 4, which is 16, and with 63 over 2 multiplied by with 63 over 2, which is going to be what? 63 all over what? All over 4. So here I'm going to have a squared equals 8 plus 2 root 16 minus 63 over 4, finding the LCM, which is 64. So here I'm going to have 64 minus 63, so which is 1 over 4. So here I have 1 over 4. So I have my a squared to be equals to 8 plus 2 multiplied by root 1 over 4, which is 1 over 2. So cancelling out, a squared will be 8 plus 1, which is the same thing as 9. So my square root is going to be what? It's going to be 3. Don't forget that my a is assumed to be greater than 0. So that shows that what? This answer. We have root x plus negative x equals 2. To solve this, we assume that the value of x here is greater or equals to 2. It is greater or equals to 0. So in solving this, we have that root x equals 2. Moving the plus negative x and negative x to the other side, I'm going to have negative minus negative x. So squaring both sides, I'm having root x all squared equals 2 minus root negative x all squared. So squaring a root is going to cancel out. So here I'm going to have x equals, the shortcut to do this is when you have a minus b all squared is the same thing as a squared minus b squared plus b squared minus 2ab. Yes. So in this regard, I'm going to have 2 squared, which is the same thing as 4, minus root negative x times root negative s is going to give me what? Negative x minus 4 root negative x. So solving this further, I'm going to have x plus x negative 4 equals negative 4 root negative x. So I have 2x negative 4 equals negative 4 root negative x. Dividing through by 2 by 2 by 2. So I'm going to have x minus 2 equals negative 2 root negative x. So squaring both sides again, and doing the same thing I did here. So on this left hand side, I'm going to have x squared negative 4x plus 4 equals negative 4x. So with this, I have my x squared plus 4 equals negative 4x plus 4x. So I have x squared equals negative 4. Square root both sides. So I'm going to have x equals root negative 4. And for you to get the solution to this root, this is going to be what? A complex number. So my x is equals to plus or minus 2i, where my I stand for the what? The imaginary. So thank you very much. We have x raised to power x raised to power 4 equals 64. So the first step for us to do here in solving for x is to raise both sides to the power of 4. So don't forget the rule of indices that says that a raised to power m multiplied by a raised to power n is the same thing as a raised to power m n, which is still the same thing as a raised to power n m. Okay, so we are going to apply this. So applying this to this left hand side, so I'm going to have s raised to power x raised to power 4 multiplied by 4, which is the same thing as 64 raised to power 4. So applying the rule of indices, this can be written as s raised to power 4 raised to power x raised to power 4, which is equals to 8 raised to power 2 or raised to power 4. So let my y to be equals to s raised to power 4. So we have on the left hand side y raised to power y equals 8 raised to power 2 multiplied by 4 is the same thing as 8. So from here it is very obvious that my y equals to 8. So since my y equals to 8, and don't forget that y is the same thing as s raised to power 4, which is equals to 8. So x is equals to plus or minus the 4th root of 8. Thank you very much. Please kindly subscribe. Hello viewers, welcome back to Hajjady math class. Today we want to solve this, but before we proceed, please don't forget to give this a thumbs up. So we have 1 plus 29 over 145 to the power of n equals 1296 over 625. So for us to proceed, the first thing we need to do is to solve this, what is inside the parentheses. And for us to do that, we have 1 plus 29 over 145. So we can divide this by saying 29, 1, here we have 5. So rewriting this, we have 1 plus 1 over 5. So finding the LCM of these, we have 5 plus 1, which gives 6 over 5. So replacing that with this. So writing our question, we have 6 over 5 to the power of n equals 1296 over 625. So now going to the left hand side, I have that 1296 is the same thing as saying 6 to the power of 4. Also 625 is the same as saying 5 to the power of 4. So writing that here, I'm going to have 6 over 5 to the power of n equals 6 to the power of 4 over 5 to the power of 4. And don't forget the rule of indices that says that a to the power of m over a to the power of n is the same thing as, m is the same thing as saying a to the power of m, since they have the same power. So here I'm going to have 6 over 4 to the power of n equals 6 over 5 to the power of 4. In addition to this, there's another rule that says that a to the power of b equals a to the power of c. So we can have our b to be equals to c. So finally, my n equals 4. Thank you very much for watching my videos. Please kindly subscribe to my channel to support this channel. See you next video. Thank you. Hello viewers, welcome back to Hajjady math class. Today we are going to solve this question 2 to the power of 100 minus 2 to the power of 99. But before we proceed, please don't forget to give this a thumbs up. Okay, so we're writing 2 to the power of 100 as 2 to the power of 99 plus 1 minus 2 to the power of 99. Don't forget the rule of indices that says that a to the power of m plus n is the same thing as saying a to the power of m multiplied by a to the power of n. So rewriting this using the same approach, so this is the same thing as saying 2 to the power of 99 multiplied by 2 to the power of 1 minus 2 to the power of 99. So with this, we can factor out 2, which is common to both, 2 to the power of 99, which is common to both sides. So for us to factor that out, we are going to have 2 to the power of 99. So we have 2 to the power of 1, which is 2, minus 1. So with this, we have 2 to the power of 99 multiplied by 1, which is the same thing as 2 to the power of 99. And that completes our solution to this question. Please don't forget to subscribe to this channel. See you next video. Hello viewers, welcome to Hajjady math class. Today we'll be simplifying this. Before we proceed, don't forget to give this a thumbs up. So we have that simplify a to the power of 8 plus a to the power of 8 plus a to the power of 8 and this. So the first thing we have to do is that, okay, let's say let a to the power of 88 to be equals to y. So with this, then we can have that y plus y plus y plus y. So this is going to give us 4y. So that means that this is the same thing as we're writing the question as 4 parentheses a to the power of what? 88. So with this, we can simplify 4 in index form. So the 4 is the same thing as writing 2 to the power of 2. And my 8 is the same thing as writing 2 to the power of 3, 88. And don't forget the rule of indices that says that when you have a to the power of m, n is the same thing as saying a m multiplied by n. So using that here, so I'm going to have 2 to the power of 2 multiplied by 2 to the power of 3 times 88. So this is the same thing as saying 2 to the power of 2 times 2 to the power of 264. So using the rule of indices also that says that a to the power of m multiplied by a to the power of n is the same thing as saying a to the power of m plus n. So finally I'm going to have 2 to the power of 2 plus 264. And lastly, I'm going to have 2 to the power of 266. So this is going to be my final answer. Thank you very much for watching my videos. Please kindly subscribe. Thank you. Hello viewers, welcome back to Hajjady math class. Today we shall be solving this question. But before we proceed, please don't forget to give this a thumbs up. So the first thing for us to do is to name this our equation 1 and name this our equation 2. So the first step is to multiply equation 1 and 2. So we multiply 1 by what? 2. So for us to do that, we have that 2 to the power of a multiplied by 2 to the power of b multiplied by 3 to the power of a multiplied by 3 to the power of b. This equal to 12 multiplied by 18. And don't forget from the rule of indices that if you have a to the power of m multiplied by a to the power of n is the same thing as saying a to the power of m plus n. So the same thing will be used to proceed with this question. So here we have 2 to the power of a plus b multiplied by 3 to the power of a plus b. So 12 can be splitted as 6 multiplied by 2, while 18 can be written as 6 multiplied by 3. So with this, there's another rule of indices I would like to mention here, which is when you have a to the power of m multiplied by b to the power of m, this is the same thing as saying ab to the power of m. So that is, when you have the same power, then you can multiply the bases together while you repeat the power. So using the same thing here, I'm going to have 2 multiplied by 3, which is going to give me 6 to the power of what? A plus b equal 6. 2 multiplied by 3 here is the same thing as 6. So here we have 6 multiplied by 6 multiplied by 6, which is the same thing as saying 6 to the power of 3. Again, the rule of indices that says that if you have a to the power of n equal a to the power of n, then you say that m equals n. So using the same rule, then I can say that here I'm going to have a plus b equal 3. Let me call that equation 4. Equation 3. So let's proceed with this. Also, the next step for us to do is to divide equation 1 by 2. So equation 1 is 2 to the power of a multiplied by 3 to the power of b over 2 to the power of b multiplied by 3 to the power of a equal 12 over 18. So for us to produce with this, to proceed with this, we have that 2 to the power of a over 2 to the power of b multiplied by 3 to the power of b over 3 to the power of a equal 2 over 3. That is, dividing this by 6, you have 2. Dividing 18 by 6, you have 3. So, using the rule of indices also for this, I'm going to have 2 to the power of a minus b multiplied by 3 to the power of b minus a equals 2 over 3. So with this, I'm going to have 2 to the power of a minus b over 3 to the power of a minus b, because this is the same thing as writing minus a minus b. Okay, and this in reciprocal form, this can be in reciprocal form. So we have this equals 2 over 3. So with this, we can form equation 4. So forming my equation 4, I can have that since we have the same power, so here I have 2 over 3. My power is going to be a minus b equal 2 over 3 equal to the power of 1. So forming equation 4, I have a minus b equal 1. Let me call that my equation 4. So now, combining these two equations together, here, equation 3, which is a plus b equal 3, and then equation 4, which is a minus b equal 1. Adding the two equations together, I'm going to have 2a equal 4. So dividing both sides by the coefficient of a, which is 2. So here my a equal 2. So when you plug in a equals 2 into equation 4, so you can have equation 3 or 4, you have a plus b equals 3, which is my equation 3. So since my a is 2, we have 2 plus b equals 3, and then finally b equals 1. So for the pairs a comma b equal 2 comma 1. So this is my answer. Thank you very much for watching my video. Please don't forget to subscribe to this channel. Thank you. Hello viewers, welcome back to Hajjady math class. Find the area of the blue shaded triangle. But before we proceed, please don't forget to subscribe to my YouTube channel. So doing this, the first thing we need to do is to connect the radius E and F with 0, that is E then and also from 0 to F. So doing this, we have that since OD is 12, we have our side OD, which is 12 units. So our OF also is going to be 12 units. And the same thing with OE. So OE is also 12 units. So with this, we call the circle from the circle theorem that we have the rule of the tangent, and we have this from the circle theorem with that this is going to be 90 degrees. So using the same rule, this is going to be 90 degrees. So we have being the tangent, this should give us what? Angle 90 degrees. with this, a square is being formed. Okay, so once we have a square to be formed, then we can say that OE, which is also 12, and OF, which is also 12, is the same thing as OF, which is the same thing as OD, which is the same thing as 12 units. Okay, so if we have this and we have that our AB is 32 units and BE is 12 units, so very much we should know that our AE should be 22 units. So doing that, since we have that our AE should be 32 minus 12, so we have that to be what? 20 units. So labeling that, we should have this to be 20 units and have this to be what? 12 units. 12 units. So that is the first batch of what we need to do. And also, you need to recall from the circle theorem under the tangent theorem also that if you have two tangent segments, if they are drawn to one circle from the same external point, they are congruent. So what do I mean? What I mean is that, take for instance, you have a circle and you have this drawn, this drawn. So these two lines are what? They are going to be the same. Take for instance, you have this to be A to be B. So you have your A to be equals to B. So the same thing will be applied here. So that is our AE must be equals to AD. And provided our AE is 20, so definitely AD is going to be 20. So that is another value we have. So we have that AE equals to AD, which is the same thing as 20 units. Then also, using the same approach, the congruent, the tangent theorem, that is FC and also DC must be the same. So since that is unknown, we can assume that to be what? Y units and also Y units. That is, we have FC to be equals to DC, which is the same thing as what? Y unit, which is unknown. So with this, we can say that our BC, that is from B down to C, is going to be addition of Y plus 12. So we have Y plus 12 units. And also from A to D, since A is 20, then AD is going to be 20. So AD, which is 20. So my AC is going to be Y plus 20. And I believe with this, a new triangle can be formed. So forming a new triangle, a right angle triangle with this, we have A, B, and C. So assigning value to this, we can have this to be 20 plus Y, that is my A to C, and my A to B, which is known as 32. My B to C, which is what? 12 plus Y. So using the rule of Pythagoras theorem, so using the Pythagoras theorem, we have that C squared equals A squared plus B squared, that is 20 plus Y squared equals 32 squared plus 12 plus Y squared. So expanding this, I'm going to have Y squared plus 40y plus 400 equal 32 squared, which is going to give me 1024, plus y squared plus 24y plus 144. So, using the numerical approach or the normal basic mathematics, y squared is going to cancel out y squared. Then I can have 40y minus 24y equal 1024 plus 144 is going to give me 1168 minus 400. So with this, I'm going to have 16y, which is equals to 768. And finally, y is going to be 48. So I've gotten the value for my y to be 48. So with this, we have that BC, which is y plus 12, which is 48 plus 12, is going to be 60 units. And also AC, which is y plus 20, which is 48 plus 20, which is also going to be 68. And don't forget, from the formula for the area of a triangle, we have our area of triangle to be equals to half multiplied by the base times the height. So this is going to be half multiplied by the base, which is 32. The base is going to be 60 multiplied by height, which is 32. So finally, my area is going to be 960 square units. Thank you very much for watching my videos. Please, if you have any suggestion, kindly put it in the comment section. And please don't forget that the diagram is not 100% accurate. So any value being made is based on assumption. Okay? Thank you very much for watching my videos. Thank you. Hello viewers, welcome back to Hajjady math class. Today we want to find the perimeter of this shape. And please don't forget that the diagram is not 100% correct. So there are some assumptions that I'm going to make that is going to be in line with this general assumption that the diagram is not 100% correct. So the horizontal line here is 19. So that is the horizontal line below should also sum up to 19. That is, if you have this horizontal line A, B, C, D, E, everything should sum up to 19. That is, the first assumption is that from a horizontal line, which is the same thing as A plus B plus C plus D plus E, this should be 19. So generally, from a horizontal line, just like considering this kind of diagram, we have A, B, B. So A and A must be equal. So from a horizontal line, I have it to be 2 times 19. That is 19 appearing twice, which is 38 units. So now we need to focus on the vertical line. So now focusing on the vertical line, we have this to be length 8 units, so simultaneously this is also going to be length 8 units. Also, we have this length to be 3 units, and we have this total length to be 5 units. That is, if this to this place should also be the same, that is more or less like a parallel line. So considering the line, a straight line like that, so that is from here to this place, I should have my 3 units. So, and if that is the case, so from here to this place, since I'm having 5 units here, and everything here too should be 5 units, and I've gotten 3 units here, so this should also be 2 units to sum up 5 units, and the remaining length here should be 3 units. So that is 3 plus 2 plus 3 should sum up to 8 units. Now using that, 3 and 2, that is from here to this place is 2 units, and if I should have that, tracing it down here, that is from this to this place is 2 units, and if that is the case, and I'm having everything here to be 9, so that means this place from here down here should be 7 units, because correspondingly we have 7 plus 2, 7 plus 2, which is the same thing as 9 units. So we've gotten that, and with that, we've gotten the first vertical line, the second vertical line, the third vertical line, the fourth, the fifth, and also the sixth. So summing up our vertical line, so I'm going to have 7 plus 3 plus 8 plus 3 plus 2 plus 3, which also sum up to 8, plus 5, and lastly plus 9. And this is the same thing as 40 units. So to calculate the perimeter, don't forget that the perimeter is the same thing as the total length of the shape. So which is equivalently the same thing as saying the total horizontal unit plus the vertical unit sum up to be our perimeter, which is 38 plus 40, then my perimeter is going to be 78 units. Thank you very much for watching my video. Please don't forget to subscribe to this channel. See you next video. Hello viewers, welcome back to Hajjady class. Here we want to solve x plus 2xy plus y equals to 18. So doing this, the first thing we need to do is to factorize x. So here we're going to have x into bracket 1 plus 2y plus y equals to 18. Now looking at this, we can see that there's nothing for us to factorize here, so we do this. Multiply both sides by what? By 2. So doing that, we're going to have 2x 1 plus 2y plus 2y equal 2 multiplied by 18 is going to give us 36. Okay, so with this, add 1 to both sides. Okay, add 1 to both sides so that we can able to factor out 1 plus 2y. So here we have 2x 1 plus 2y plus 1 plus 2y equal 36 plus 1. So with this, we have 1 plus 2y, 1 plus 2y, which is easy for us to factor out. So with this, we are going to have 1 plus 2y, 2x plus 1 equal 37. Now looking at this value, we have 37 here. 37, the factor of 37, since 37 is a prime number, it can have only two factors, so with different signs. So here we have 1 multiplied by 37, that is the first condition. Okay, we can have 37 multiplied by 1, we can have negative 1 multiplied by 37, lastly we can have negative 37, negative multiplied by negative 1. So these are the four conditions we're going to have. So we are going to put this into consideration. So for case 1, so we have 2y plus 1 equals 1, and we also have 2x plus 1 equals 37. So with this, we have that our y will be 0 and x is going to be 18. That's for the case 1. So this is gone. For case number 2, so we have 2y plus 1 equals to 37, and here we have 2x plus 1 equals to 1. So we have y to be 18, x to be 0. That is for case 2. So we move straight to case 3. For case 3, that is, we consider the negative part of it. We have 2y plus 1 equals to negative 1. 2x plus 1 equal negative 37. With that, we're going to have y to be negative 1 and x to be negative 19. So we've done this. And the last rule, which is case 4. For case 4, we have 2y plus 1 equal negative 37. 2x plus 1 equal negative 1. So with this, we're going to have y to be negative 19 and x to be negative 1. So these are the solutions and also the values for the question given to us. Please don't forget to subscribe to my YouTube channel. See you next video. Thank you. Hello viewers, welcome to Hajjady math class. Today we want to make K the subject of the formula using the equation given to us here. Now looking at this equation, the first question I'm going to ask is that what kind of equation is this? So looking at this critically, it's very obvious that this is a quadratic equation. And what makes this to be a quadratic equation? It is the what? The order of 2. Don't forget that a quadratic equation is of the form a x squared plus b x plus c equals to 0. Okay, so we're going to make this look like the general form of a quadratic equation. So by so doing, we're going to have yk squared plus 2kx minus n equals to 0. So this is the same thing as the general case of a what? A quadratic equation. So doing this, we're going to make use of the general quadratic formula approach. And the general quadratic formula approach is using the formula of k equals minus b plus or minus root b squared minus 4ac all over 2a. So before we proceed using this, there's a need for us to declare what our a is, what the value of b is, and also the value of c. So doing that, we know that our b from here is the same thing as the coefficient of x, or coefficient of k. The coefficient of k here is what? Is 2x. So a is going to be the coefficient of k squared, which is what? Y. And my c is the constant term, which is what? Negative m. Don't forget the sign. So we're going to plug in the value of a, b, and c into this general quadratic formula. So doing that, we're going to have minus b, which is negative 2x, plus or minus root b squared, which is negative 2x all squared. We plug in the value of b into this. Okay, minus 4 multiplied by my a, which is y, multiplied by my c, which is what? Negative m. So dividing everything by 2 multiplied by a, which is the same thing as y. So solving this further, we're going to have negative 2x plus or minus root negative 2x to the power of 2 is the same thing as 4x squared. Negative multiplied by negative is going to give me positive. 4 times y times m is going to give us 4ym. Everything over 2y. So solving this further, we have negative 2x plus or minus root. Looking at these two, we can see for x squared, 4ym. That shows we can factor out 4. So we're going to have x squared plus ym over 2y. So we're going to have the stats. So we have negative 2x plus or minus. Taking the root of 4, we're going to have the root of 4 to be 2, square root of 4. So we are going to be left with x squared plus ym over 2y. So from here, we can factor out 2, which is common to both sides, which is 2. You're going to be left with negative x plus or minus root x squared plus ym over 2. So with this, I can have that my k equal 2 cancelling out 2. So finally, you can have negative x plus or minus root x squared plus ym. Sorry, I omitted y over y. So this is my answer. Thank you very much for watching my videos. Please don't forget to click on the subscribe button and also share this video. Thank you. See you next time. Bye. Welcome back to Hajjady math class. We want to solve 2023 factorial over 2022 factorial plus 2021 factorial. In solving this, don't forget there's a general rule that when you have your n factorial can be the same thing as n minus 1, n minus 2, up to n minus 10 if you want to stop here factorial. Okay, so that shows that the value given to you can decrease by 1, whereby you can still have your factorial with it. So the same rule is going to be applied here. So my 2023 factorial, writing it separately, can be the same thing as 2023 multiplied by 2023 minus 1, 2023 minus 2 factorial. Okay, so the same thing with others. So rewriting the above question, so we can have 2023 multiplied by 2022 multiplied by 2021 factorial. That is, it decreased by 1 over 2022 can be written using the same approach, that is 2022 multiplied by 2021 factorial, that is, it only decreased by 1 using the same rule above. So here we have 2021 factorial written the same way. Okay, so proceeding from here, we can see that here I'm having 2021 factorial, 2021 factorial is like having 2x plus x. Here we can easily factor out x, whereby you have your 2 plus 1. So I'm going to make use of the same approach. So my numerator remains the same, whereby I have 2023 multiplied by 2022 multiplied by 2021 factorial. Okay, and the denominator, so factoring out 2021 factorial, I can easily have in my parentheses 2022 plus 1, in which this can easily be multiplied out. So with this, I have that 2021 can easily cancel out, 2021 factorial can easily cancel out 2021 factorial. So I'm going to be left with 2023 multiplied by 2022 over 2022 plus 1 is going to give me 2023. So cancelling out, so finally my answer is going to be 2022. Thank you very much for watching my videos. Please kindly subscribe for more videos. See you next time. Hello viewers, welcome to Hajjady math class. Today we want to solve this question given to us here. And the first step for us to do is to let the root of x to be equals to y. And there's a condition here that the value for our y must be greater or equals to 0. That shows that y must be positive. So if root x can be equals to y, then x will be equals to y squared. So having done this, then we're going to plug in the value of root x and x into the given equation. So with that, x is going to be y to the power of 2 multiplied by root x, which is the same thing as y, equals to x, which is y to the power of 2 plus root x, which is the same thing as y. So here I'm having y to the power of 3, collecting like terms, minus y squared minus y equals to 0. So factoring out y, which is common to all, so here I'm going to have y into bracket y squared minus y minus 1 equals to 0. So here I'm having something like a quadratic equation in the parentheses. So with this, I can say that I'm having two cases here. So here, my case number 1 is that my y is equals to 0. And if y equals to 0, automatically, then my x will also be equals to 0. That is case number 1. For the case number 2, that is, we want to talk about the quadratic equation. Here we have y squared minus y minus 1 equals to 0. So we need to solve this using quadratic approach. So here, I'm going to adopt the method of quadratic formula. And my quadratic formula is y equals to minus b plus or minus square root of b squared minus 4ac all over 2a. So here, plugging in the coefficient, so my y is going to be minus -1 plus or minus root b squared, which is 1, minus 4ac, which is 4 times 1 times c, which is -1, all over 2a, which is 2 multiplied by 1. So here, my y can be equals to 1 plus or minus root 5 over 2. So here, my y can be equals to 1 plus root 5 over 2, or y can be equals to 1 minus root 5 over 2. So for the first case, we need to get the corresponding value of x. Don't forget that y is the same thing as s squared, right? So doing that, this shows that x is equals to y squared. My x is going to be 1 plus root 5 over 2 squared. So it's like multiplying it twice. So doing this, multiplying this out, we're going to have 1 plus 2 root 5 plus 5 over 2. So my x is going to be 6 plus 2 root 5 over 2. So finally, x equals to 3 plus root 5. So this is what I have. And for the second case of my y, here it's very obvious that the value of y is less than 0 because square root of 5 is more than 1. So we're going to have negative. So in this case, we're going to ignore this. So the two values for x is going to be this and also 0. Thank you very much for watching my videos. See you next time. Thank you. Viewers, welcome to the Hajjady math class. Now today we want to solve this question given to us there. Now the first thing we need to solve is to solve this 7 to the power of 0. So that's anything raised to the power of 0 is going to be 1. So here I'm having 1 plus 3 multiplied by 5 multiplied by 17 times 257 all to the power of 1 over 16. Yeah, I'm going to use an approach here and I want you to please concentrate on this. So here I'm having 1 plus 3 can be written as 4 minus 1. That is the same thing as 3. My 5 can be written as 4 plus 1. Okay? Multiplied by 17 can be written as 16 plus 1. And also 257 can be written as 256 plus 1. All to the power of 1 over 16. So with this, I'm going to make use of a rule as rule of difference of two squares when you have s squared minus y squared, which is the same thing as x plus y, x minus y. Now look at these two. This is like my x minus y,